Good morning, guys. I'm going to talk to you about continental drift and Alfred Wegener. And this is what you should have been reading and watching videos over and answering questions this week. I just want to kind of give it a summarize it for you today. I have loaded a quizzes for you to practice over the things that you've learned this week. All right. You should be able to tell me who is Alfred Wegener. What is the historical evidence that supports the continental drift theory? What causes the movement of the continents? We're going to focus on Wegener and continental drift. This is a picture of Mr. Wegener. Now, I say Wegener because he's a German scientist, and if you look up the correct pronunciation, the W is pronounced with a V. You'll hear a lot of the videos made in the United States and America as Wegener, so either one is appropriate. He was a young German scientist who became curious about the relationship of the continents and proposed the continental drift theory in 1910. He gathered information from fossils, glaciers, and rock evidence. That is the evidence that Wegener had that he presented to other scientists. But his theory was rejected by most other scientists of his day because he could not explain how the continents moved. So one of the questions you were supposed to figure out this week was, why didn't they accept Wegener's theory? It was because he could not explain how the continents moved. The idea that Earth's continents moved apart from a single large continent called Pangaea. That's what continental drift is. It was only in the 1960s that Harry Hess discovered seafloor spreading. Seafloor spreading led to the continental drift theory finally being accepted and became part of the theory of plate tectonics. And we'll talk about seafloor spreading next. I'm not going to show the video. You can try and see if it'll work for you at home. Pangaea. Pangaea was a supercontinent that existed about 200 million years ago. It means all Earth. And this is a theory that all the continents fit together like a piece of puzzle. And you should have read that information in your first 2 days of reading. And they also talked about it in the video. It began to break apart about 175 million years ago. There's also a theory that eventually the continents will float back together millions and millions of years into the future. Laurasia and Gondwanaland was what the two, when it first separated 200 million years ago, was the two pieces of land that and what it was called. Gondwanaland separated from Laurasia between 200 and 180 million years ago. This roughly formed the northern and southern hemispheres. Wegener's supporting evidence. Fossil evidence, continental fit, how they fit together like a puzzle, landforms and rock layers, and then glacial evidence. Fossils of the same species were found on continents now separated by oceans. These plants and animals would have had to evolve independently or swim the distances. If the theory of the continents not fitting together, to prove the theory using fossils the way the continents are now, then the animals would have had to either evolve or swim the distances. That's what that means. Fossils found didn't fit the climate. Palm tree leaf fossils were found in Alaska. You got to think about what we know about Alaska. What do we know about Alaska? It's very cold, and there's not a lot of vegetation in that area. The continents, particularly South America and Africa, appear to fit together like pieces of puzzles. This was another piece of evidence that suggested the continents were once joined. Glacial evidence. Glacial deposits formed 300 million years ago are found in Antarctica, Africa, South America, India, and Australia. Evidence of glaciers is found in warm climates today. Striations. These are scratches on rocks that show the ice flowing from the glaciers came from a single point. Landform and rock layers. The Appalachian mountain chain matched well with mountains on the British Isles as well as other places. Rocks of similar types and ages matched on North America and Africa. Coal fields in North America and Europe match. Okay, now I have gone over Wagner, the German scientist. I have told you what continental drift theory is, and I've talked to you about the evidence that Wagner used and why his theory wasn't supported. Those are the things that you need to remember from your readings and your video this week, and what all of your questions were over this week. And yes, I know the questions were a little bit repetitive, but I wanted you to retain the information. You can go back through this and look at I'm going to load it into I'm going to load the actual PowerPoint into Google, that you can go back through it, or you can just go back through it through the video, also pausing it and rereading the information. You guys did a good job getting started back this week. I'll have a new assignment on Tuesday.